Good morning everyone. Myself Nageshwara, IIT Chemistry faculty. Today we are going to discuss about the topic metals and non-metals. Before going to discuss metals and non-metals, first of all, we can see in our daily life, in our surroundings, different type of materials. These materials are mainly classified into three types based on their properties. Those are, the first one is metals, the second one is non-metals, the third one is metalloids. Out of these three classifications, most of the materials comes under metals. Some of the materials comes under non-metals, but very few materials comes under metalloids, which are having the properties of both the metals and non-metals. Now today in this class, we are going to discuss about metals. Now let us start with the physical properties of the metals. What are the physical properties of the metals? The first physical property is nothing but hardness. Usually all metals are comes under solid in nature. You can see any type of metal, all metals are solid in nature except only one metal, that is mercury, which we can see in clinical thermometer, except mercury. Because it is liquid in state. Apart from this mercury, two more metals are not comes under hard metals, because those two metals are very soft and which we can cut with knife also. Those two metals are sodium and potassium. That means mercury is a liquid and sodium and potassium comes under soft in nature. Except these three, remaining all metals are comes under hardness. The second property is nothing but lustrous. Lustrous is nothing but shining. Usually metals having the property is nothing but shining in nature. You know most of the metals, that means like gold, silver, copper or some other metals we are using because we are using widely because of having one property is nothing but shining. For example, in jewelry we are using mainly silver and gold articles because they are more shining in nature. The next one, malleability. First of all, what is meant by malleability? Malleability is nothing but it is a property of making thin sheets. It is a property of making thin sheets. That means metals having one more characteristic, that is nothing but we can make it into thin sheets. We can make it into thin sheets. For example, if you go any sweet shop and you can see some sweets are decorated by a silver layer. That means the layer is made up of what? Silver. Silver comes under metal. By using metals only we can make it into a thin sheets or thin foils. That is why metals having the property malleability. Malleability means making into thin sheets. The next one, ductility. Ductility. That means the property of making thin wires. The property of making thin wires. You know, in electrical purpose we are using different type of wires which are made up of aluminum and copper. Aluminum and copper. Because metals only can able to make it into thin wires. You can make you can make nearly 2 kilometers wide by using 1 gram of gold, because metal only having the nature you can make a thin wire, a thin wire. The next property, conductivity. Usually, generally metals are good conductors of electricity. This is about some physical properties of the metals. Now let us discuss about the chemical properties of the metals. What is meant by chemical property? Based on the chemical property also, we can conclude that these all metals are having similar properties. What is meant by chemical properties means how these metals are react with other compounds and what they are giving. That we are going to discuss about in chemical properties. Let us discuss. The first one is oxidation. Oxidation is nothing but reaction with oxygen. Usually metals all are highly react with oxygen. Every metal react with oxygen. But except two metals, those are silver and gold. These are comes under noble metals. They have very less reactive nature with the oxygen. That's why we are using in jewelry purpose. They won't get rust that much easily. Apart from these two, remaining all metals, they have nature and they are easily react with the oxygen. For example, let us take magnesium with oxygen to produce its respect to oxide, magnesium oxide. Magnesium oxide. In this oxidation, let us see two more general examples which we can see in our daily life. The first one is rusting of iron. Rusting of iron means if you keep any iron articles in presence of free air and moisture, then you can see after a few days a brown color layer is formed on the surface. The brown color layer we can call as rust. How it is formed means iron article, that means Fe, react in presence of oxygen and in the presence of moist air, moisture, it produces a brown color compound is nothing but Fe2O3. Iron oxide having the color brown layer. This is nothing but rusting of iron. Here also the reaction takes place in the presence of oxygen. That is why rusting of iron is comes under oxidation. Same like rusting of iron only, we can see another rusting of another metal, that is nothing but rusting of copper. You may think that maybe you didn't observe that. When you observe these copper vessels, you can see some type of green color dots will form. The green color component is nothing but rusting of copper. But here, rusting of iron is nothing but a compound. But rusting of, that means the green color layer which is formed on the copper vessels is not a compound. It is a mixture. Let us see how it is formed. Rusting of copper vessels. Copper react in presence of oxygen as well as carbon dioxide as well as moisture then it form a compound is nothing but copper hydroxide plus copper carbonate. This is copper hydroxide plus copper carbonate. This total mixture only nothing but green color rust. This is how copper vessels get rust. That means copper react with oxygen and carbon dioxide present in the atmosphere and moist air to produce a mixture contains copper hydroxide and copper carbonate. Here the total mixture is nothing but a green color rust. That means you can see iron vessels form a brown color layer but copper vessels form a green color layer. This is the first chemical property. Let us see the second chemical property. Reaction with acids. That means if metals react with acids, what will happen? Let us see. Metal plus acid produce salt plus hydrogen gas. Salt plus hydrogen gas. Let us see one example. Zinc plus HCl. Hydrochloric acid. Hydrochloric acid. Aqueous. To give ZnCl2 plus hydrogen gas. Produce ZnCl2, zinc chloride plus hydrogen gas. For balancing, just keep 2HCl here. That means metals react with acids to produce its respective salt and hydrogen gas. This hydrogen gas you can identify very easily by using one identification test. That means just collect this hydrogen gas in a vessel and take one burning matchstick and just keep near to that vessel, just open it, then the hydrogen gas burn with a pop sound. The pop sound indicates the unknown gas which is releasing in the following reaction is nothing but hydrogen gas. Likewise, we can identify hydrogen gas. Let us take one more example. Zinc plus another acid, sulfuric acid. Then it produces zinc sulfate plus hydrogen gas. Based on this, we can conclude that metals usually react with acids to produce respective salt and hydrogen gas. Now, how it is react with bases? Reaction with bases. Usually, metals react with bases. They will also produce hydrogen gas. Let us take one example. Zinc plus NaOH, sodium hydroxide. Then it produces a salt, sodium zincate, Na2, ZnO2, sodium zincate plus hydrogen gas. Gas always indicate by using upward arrow. This is how metals react with acids and metals react with bases. Let us see one more example. Reaction with water. Normally, different metals are react with water in a different ways. That means some metals are vigorously react with water, but some metals are slowly react with water. For example, if you take sodium is highly react with water. But whereas iron, copper are less react with water. Means reaction with water is different with different type of metals. But usually metals react with water to produce respective hydroxides. Let us take one example. Zn plus H2O gives rise to ZnOH twice. Magnesium plus H2O gives rise to MgOH twice. That means if you take any metal, they will produce their respective hydroxides. This is about reaction with water. Let us discuss the last and final example is nothing but displacement reaction. Displacement reaction. What is this displacement reaction? Means one metal react with another metallic salt. Then what will happen? Let us take one example. Iron plus copper sulfate. This is copper sulfate. Then what will happen? Usually iron is more reactive than copper. Iron is more reactive than copper. Therefore, iron can easily replaces the position of the copper and it forms iron sulfate and copper. But in the case of opposite, like copper plus, if you take iron sulfate, then here no reaction takes place, because always highly reactive can able to displace less reactive metal by its respect to salt, but less reactive metal cannot able to displace highly reactive metal. Therefore, displacement reaction means highly reactive metals displace less reactive metals by its respective salts. Let's take one more example. Zinc plus iron sulfate gives rise to ZnSO4 plus Fe. Based on this, we can write the reactivity series. Zinc is more reactive than iron. Iron is more reactive than copper. This is about some important chemical properties of the metals. The last and final one, uses of the metals. Now, we are using metals widely in different purposes. Let us take, in jewelry purpose we are using gold and silver. Widely we are using. And iron is the main important metal for industrial purposes. I think maybe we don't have life without iron. Maybe because most of the industries, they are mainly based on iron. Copper wires we are using, aluminum wires we are using. Like this, different type of metals we are using for different type of purposes in our daily life. Thank you so much.